I'm still seeing your window there, Trish. I don't know why I can't get rid of yours.
Hey everyone, I'm Michael Unger, the program coordinator here at the H.R. McMillan Space Center. If you've ever come into the building before, you may have noticed the shape of the building. Some people think it looks like a UFO, others, a hide-a-hat. And that's a good reminder, because this building, built in 1968, was built on the unceded territory of the Musqueam, the Squamish, and the Tsleil-Waututh nations. In front of the building, you'll notice that there's a large crab sculpture that was placed here in 1968 by George Norris. And the crab has two meanings. One, the crab is a symbol of the zodiac, Cancer. But also, the First Nations people believed that the crab was a protector of the inlet. Looks pretty cool, doesn't it?
All right, hello everyone. Michael Unger here from my kitchen. Welcome to another edition of Cosmic Nights Virtual Edition. This month's theme, because I guess we've been doing almost every month, is a really exciting one, and I hope that you all are here to dive into this month's theme, which is Mars. Now, if you've been to a Cosmic Night before, put into the chat. Let us know where you're viewing from. If you're out there on Telus Optic watching, hopefully next time you can come on into our Zoom webinar so you can interact. But we'd love to hear from you sometime in the future. And Cosmic Nights are this chance to kind of delve in deep into subject matters, and we're really excited. We've got a couple talks that we're going to have today, but also we'd love to have a really lovely discussion with everyone here. That's why we've gathered everyone in the Zoom webinar. So as we sort of go through, if you're new to Zoom webinar, there are a couple different ways that you can interact with us. You can use the chat feature. So there you can throw in where you're viewing from. You can also chat amongst each other. But if you want to ask questions, we want to direct you to the Q&A feature. And the really cool thing with the Q&A feature is that you can put in a question, and you see somebody else's question that you really like, you can upvote it. And that way, because we're going to have a lot of people joining us here today, and we're going to go till about 8 o'clock or so. And if we don't get everyone's questions, then we'll try to type in the answers directly, as I don't think we'll be able to get to everyone's questions, but we'll try to. And then, of course, Cosmic Night, as I said, is this chance to kind of delve in deep. If we were in the building, we'd probably be having some alcoholic beverages. So I'm going to throw up our first poll of the night to see what everyone is drinking tonight. Now, of course, working from home allows me to use my trusty soda stream. Don't go anywhere without it. Throw into the poll what everyone is drinking, and then I'd love to hear if anyone has a special concoction for tonight as well. When we sent out our invites, we also invited some of you to make some Mars culinary dishes. Maybe not dishes, but perhaps using candy, perhaps using pasta. If you did make some, you should totally send us a picture, send it to info@Space Center, where we can share some of those, maybe tonight, but maybe also on our social media channels in the future. So I'm going to end the poll here. Let's see what we got. Of course, everyone's drinking water because it's super hot in Vancouver right now. Too hot for me as well. Oh, the other. I wonder what the other is. Throw into the chat what everyone's drinking tonight. What, did I not share the results? Here we go. Now you can see the results. There you go. Sharing the results. Got some beer drinkers, got some wine drinkers, but of course that water is very popular. So it's not just going to be me getting into Mars. I'm sure all of you are very excited. There's a bunch of missions going to Mars right now. Just a few days ago, the UAE, the United Arab Emirates, just launched their mission called HOPE to Mars. And in a few days, the Chinese are going to be launching. And then, of course, on July 30th, NASA going to be sending Mars Perseverance rover. So we've got lots to talk about, and we've got a couple special guests, of course. My colleague who I miss and I haven't seen in a while working from home, and that is our astronomer, Rachel Wang. How's it going, Rachel?
Going great, thanks. How about yourself?
Oh, not bad. How's the heat over there? I see you're wearing a sweater, which I can't believe.
Well, because I live in a sub-basement, so all the cool air ends up sinking down to me, so that's fantastic for the summer.
Yeah, you're trying to get that Mars vibe, because it is,
yeah.
Even in the summertime on Mars, it's still pretty cold, isn't it?
It is.
And of course, Rachel's going to give a short little presentation, going to use our UniView software to kind of simulate what it might be like in the planetarium. And then a little bit after that, we are going to have our featured speaker tonight. We're so excited to have all the way from Chicago. She is an astrophysics major from the University of Chicago. During the summertime, she is working for the Jet Propulsion Laboratory. That is so cool. That is Joalda Morancy. Hi, Joalda. How are you?
Hi, everyone. I'm pretty good. You know, just
how's the heat in Chicago today?
It's so hot. It's like hot every single day. It's unfortunate.
Awesome. So a little bit later on, Joalda, you're going to be giving us a presentation about the human experience going to Mars. So we're going to have a chance to delve into that. But we're going to get a little bit of an icebreaker here. And this is, of course, is for everyone out there watching as well. And I'll go to you first, Joalda. And our first big poll of the day, and of course, is the question that really at the heart of the matter is, would you go to Mars?
So I guess I'll start.
Yeah.
For me personally, that's been my goal ever since I was a teenager. When I was 15 and I started getting into space, it's been Mars that I've always wanted to walk on. So it's like my ultimate life goal sort of thing. So I would go to Mars definitely in a heartbeat.
And what was it like? Was there something that drew you to Mars? Like, was there like a moment? Was it going to the planetarium? Was it watching a movie or reading a book? Like, what was sort of like that first impetus that made you fall in love with Mars?
Yeah, so it was actually a YouTube video, funnily enough, and it's nothing too spectacular. But when I started watching more space videos online, once they were in my recommendation feed, I saw a lot of videos on NASA's journey to Mars, and I was like, wow, this is something I could do in the future. So, yeah.
Awesome. Well, I certainly hope that you get to fulfill that dream. How about you, Rachel?
Oh, absolutely. Yeah, for sure. I think it's really cool to be able to be the first person to do something, being a pioneer for a species, because, humans have been around for a really long time. It's hard to claim being the first person to do something. We've been to the moon already. We haven't had a female walk on the moon yet, but they're hoping for that in 2024. So I'm thinking that Mars is the one that I'm going to try to claim as the first.
Okay. I think for me, I think I would have to put some caveats in there because I'm a claustrophobic person. So at the moment, the thought of being in a small rocket capsule for that amount of time, like what are we talking here? Like probably like 8 months for humans, Joalda, maybe?
Yeah, 8 months.
Yeah, like I mean, I can't even. I'm getting claustrophobic here just in my kitchen for like a couple hours. So I would totally go to Mars, but for me, I think it would need to be some kind of different system. Maybe getting there quicker, or maybe I could go. It could be put in cryogenic sleep for a while. I'm not sure, but we're going to delve into that a little bit later. And of course, here's our results from our poll. 59%. Wow, that's a lot closer than I thought. 59% of everyone here said yes, 41% said no, perhaps maybe with some of my caveats as well. Like, I mean, of course, if you just transport there immediately, like who wouldn't come up? I think really when it comes down to it is that long journey that's going to be the problem. So before we go to our first presentation, Rachel, we're going to get all jazzed up. Everyone get their drinks all ready. We're going to take a quick little break and watch a quick little video preview of the NASA 2020 rover. All right. I think one of my favorite things about the Mars 2020 rover is that it has a Mars copter on it. I am super excited to learn about that. But let's go now to Rachel, who's going to take us out into space and give us the cosmic perspective of Mars and our planet Earth. So take it away, Rachel.
For sure. Thanks, Michael. So I'm just booting up our UniView software, which is the same software that we use in the planetarium. So you'll notice that instead of a rectangle, it looks like a circle because this fisheye view would be projected onto our dome. But thankfully, because we have the software here right at home, I can show you the beauty of the cosmos right here from my bedroom. Now, we have a planet in our solar system that scientists think could be our second home. Now, although our planet is mostly blues and greens, and this planet is mostly red, it has a lot more in common with our home planet than you might think. So let's take a short flight to this red planet called Mars. Now, the reddish color of Mars helps us distinguish it from other planets. One of its earliest recorded names literally meant red one in Egyptian. So why is it red? Well, if you've ever left your bike outside while it rains, you might have noticed that some parts of the metal look a little red. The red that you see on your bike after being left outside is the same kind of thing that's happening to Mars's surface. It's because of rust. Now, the Martian soil has tons of iron minerals, like your bike does, which turns red when it oxidizes or rusts, causing the soil and the atmosphere to look a little red. So the same thing that's happening on Earth to your bike is also happening on Mars. Now, just like Earth, Mars has many moons. It has twice as many, in fact, and we'll fly to one of them right now. Now, it has two small moons, one named Phobos and the other one named Deimos. Now, both moons were discovered in 1877 by American astronomer Asaph Hall. He named them Phobos, meaning phobia or fear, and Deimos, meaning terror or panic, after the horses that pulled the chariot of the Greek god of war, Ares, the counterpart to the Roman god of war, Mars. Now, Hall was actually about to give up his frustrating search for a Martian moon one August night in 1877, but his wife, Angelina, wouldn't let him give up and urged him on. He actually ended up discovering Deimos the next night and Phobos 6 nights after that. Now, this sequence of images shows a rough outline of this moon. The fourth image on the far right is a much closer image taken from orbit by the Mars Express. The crater here is the most dominant feature on Phobos, nearly half the width of the moon itself. and it was given Angelina's maiden name, Stickney. Now, like Earth's moon, both of these moons are always presenting the same face to their planet. They're both lumpy, heavily cratered, covered in dust and loose rocks. Now, the moon's surface materials, carbon-rich rock mixed with ice, seem to be similar to many asteroids in the outer asteroid belt, which leads most scientists to believe that Phobos and Deimos are actually captured asteroids. Now, Mars and Earth are very different planets when it comes to temperature, size, atmosphere, but geological processes on the two planets are actually surprisingly similar. On Mars, we can see things like volcanoes, canyons, and impact basins like the ones that we see on Earth. So, for example, Mars has something called the Mariner Valley. Oh, let's brighten up Mars a little bit so we can see the surface feature. And here is the Mariner Valley. It's the deepest canyon system on Mars, and it's one of the largest in the solar system. It's located on the equator of Mars, and it stretches for nearly a quarter of the planet's circumference. Now, if you compare it to the Grand Canyon, the Mariner Valley is 10 times longer at 4,000 kilometers wide and 7 kilometers deep. Now, another similar surface feature to Earth's looks like a gigantic pimple on Mars's surface. This massive mountain is a shield volcano called Olympus Mons. It's around 2.5 times as tall as Mount Everest, and it's so tall that the peak of Olympus Mons actually reaches above most of the Martian atmosphere. Now, what's cool is that Olympus Mons couldn't exist on Earth either. With Earth's stronger gravity, this massive volcano would collapse under its own weight if it were on our planet. So if you weighed 100 pounds on Earth, you would weigh only 38 pounds on Mars. In other words, you'd experience around 63% less gravity on Mars than you're used to here on Earth. Now, just like Earth has polar ice caps, Mars does too. It's very cold on Mars, being farther from the sun. It has an average surface temperature of around negative 63 degrees Celsius, whereas Earth's average temperature is around 14. Now, the polar ice caps on Earth are permanently covered with water ice, but the ones on Mars are covered with a mixture of carbon dioxide ice, or what we colloquially call dry ice, and water ice. Now, the Martian atmosphere is made of similar elements to that of Earth's, but in different proportions. Both atmospheres contain carbon dioxide, nitrogen, argon, and oxygen, but these constituents are packed much more tightly in Earth's atmosphere, making it over 100 times denser than Mars's atmosphere. Now, humans have been looking at this red planet ever since we started gazing up the night sky. The history of observation is marked by oppositions of Mars, when the planet is closest to Earth and is thus easily visible. If Earth and Mars followed perfectly circular orbits, then opposition would be as close as the two planets could get. But of course, nothing in space or reality is quite that perfect, and orbits are actually elliptical or oval-shaped. And we travel a little closer to the sun at one end of the orbit, called perihelion, than at the other end. Now, Mars's opposition happens every 26 months, and every 15 or 17 years, opposition occurs within a few weeks of Mars's perihelion, bringing it even closer to Earth. And we call these perihelic oppositions. But once again, nature likes to complicate things, and gravitational tugging by other planets constantly changes the shape of our orbits just a little bit, and Jupiter is a big contributor to this. Now, also, the orbits of Earth and Mars don't quite lie in the same plane, as you can see here. So the paths that the planets take around the sun are actually slightly tilted with respect to each other. So if we add up all these factors, some perihelic oppositions bring us closer together than others. The 2003 opposition was the closest approach in almost 60,000 years. And in fact, this record will stand all the way up until August 28th, 2087. Or 2287. Now, finally, if you wanted to take a look at Mars tonight, how would you do that and when would you go? Well, you'll have to go early in the morning around 5 a.m. and look towards the south to see this red jewel. And maybe one day we'll get to visit this planet in person, but we'll hear a little bit more about that from Joalda. So Michael, back to you, and I'll stop sharing my screen here.
Awesome. Thanks so much, Rachel. Yeah, and I already see that people are already using the Q&A feature and already upvoting questions. Awesome. If you have any questions, go into that Q&A feature, and we'll answer a few general questions to start off here, Rachel. And of course, one thing that I was kind of curious about. So you were talking about the opposition. So when Mars and Earth are closer, and as I just talked about off the top, the UAE, China, and NASA are all launching to Mars basically like in the last few weeks. So do they do that because there is that small window of when we're close to Mars?
Yeah, exactly. So it's that launch window where it costs the least amount of fuel for us to get to Mars because our Earth and Mars are so close. If we waited for Mars to be on the opposite side of the sun, it would cost way more money to send robots or people to Mars. So we wait until it's the most cost efficient and fuel efficient to do so.
I always love, and I think there was actually like a scene in The Martian as well, where they actually talk about that because they have to make those cost decisions because they're trying to figure out how long could he survive on Mars by himself with his resources, and then they were trying to calculate how fast they could get there. It was a really cool scene from that movie, which might as well go to Donna, who does actually talk about a scene from The Martian, and that's, is there a way to set up a base on Mars that could mimic Earth's gravity while you're inside, similar to the way that it is in The Martian?
Ooh, so the only way that I know that you can mimic gravity is through kind of that rotating space station that you see in sci-fi, having that centrifugal force forcing your feet down to the ground. But remember that gravity is really the pseudo force. It's really the curvature of space-time, and we need a lot of matter to be able to curve space-time. So unless we could figure out a way to give Mars a lot more matter, we wouldn't be able to increase its gravity in any way.
Cool, yeah, and of course that would be hard to simulate as well. And I think a little bit later on, Joalda took part in this really cool Mars analog project, which I'm hoping that she's going to talk about in her presentation. So we'll save that discussion for a little bit later. Let's go to the next upvoted question that comes from Jason. How would human anatomy react to the much lower gravity on Mars?
Well, that's a great question. And we actually see some of those effects on the space station because they have a microgravity environment. So not quite zero gravity because they are only 400 kilometers up in the sky. But you see things like getting your spine elongated because your spinal column pressure is not enough because gravity is the thing that's forcing your spinal column and pressing it down a little bit. And you'd probably see something like the space sniffles where the water in your body is distributed a little funny. And so you start getting these little sniffles and the space sniffles that they call on the ISS.
Oh, well, we don't need any more talk of any sort of viruses. We are done with viruses right now. Please don't send any more viruses up. We're going to have a nice time there. But maybe related to that, Pride, Shadow Pride, friend of the Space Center, would you get taller on Mars?
Yeah, so it's kind of the same idea. I don't know if you would get visibly or significantly taller just because it is 63% of what the gravity is here that we feel on Earth. So it wouldn't be super noticeable, I don't think, but I think I would maybe a few centimeters, few millimeters up on Mars, be a little bit taller.
Interesting. Yeah, and then, of course, you also talked about the lower gravity. And I don't know if have you ever seen John Carter? Or anyone else out there seeing John Carter? It was based on the Edgar Rice Burroughs books of John Carter Goes to Mars. And in the movie, because he's from Earth, he has stronger muscles, so he's actually able to bound really higher and almost has he's almost like a superhero. I don't know if that would actually happen, but science fiction does give us some of these interesting ideas because our physiology would change on Mars, right? Because of that difference in gravity.
Exactly.
Cool. So you know what? We got so many Mars questions, but I want to get Joalda into this conversation. So what we're going to do is we're just going to pause on those questions for now. We're going to take another quick little break, fill up on your drinks. We're going to watch another really cool video that I wanted to share with you because for everyone here on this webinar, you're going to get a bonus interview that you can go and watch after this webinar is done. And that is with Dr. Anna Mittelholz, a conversation I had with her. She worked on the Mars InSight lander. And it's on Mars right now doing a bunch of cool work. And if you don't know about the InSight lander, well, watch this video and you'll learn all about it. All right, so there we have the Mars Insight Lander, which is on Mars right now. There's also the Curiosity rover. And like I just mentioned, the UAE are blasting off, sending Hope to Mars. The Chinese are sending their spacecraft as well. And we're going to get Perseverance. We're going to have so much robots on Mars. But for Joalda's presentation, we're going to take the human approach. And we're going to talk about the human experience on Mars. So let's give it over to Joalda. And of course, I need your questions, throw them into the Q&A, and we'll talk about Mars, anything about, really, we'll talk about anything if you want. If you want to throw it into the Q&A, if people want to upvote it, you can upvote it. So we'll have lots of time before we get to 8 o'clock to get to all your questions. So for now, I'll hand it over to you, Joalda.
So let me share my presentation. So as you all know, my name is Joalda. I'm currently an undergrad at school, and I'm going to be talking to you all about the future of human exploration on Mars. So we've obviously, as Michael has been saying, we've seen all these like robotic missions and whatnot, and like all these like amazing things going to Mars, but it's time to talk about us as humans making that first step on a different planet. And so before I get into my presentation, I like to mention that this photo I have in the background is one of my favorite scenes from the short film called Wanderers by Eric Warnkiss. I think I said his name right. And it's basically a short film about human exploration into the solar system. And this one's specifically about Mars. Obviously, there hasn't been humans on Mars, so that part's edited. But the blue sunset is real. And it's something that some of us will get to see someday. So the topics I'm going to be discussing is the history of Mars exploration, kind of like how this all got started and what its current state right now. Then the trip to get to Mars, aka preparation, the journey to Mars, living on the red planet, and then the return home. And then I'll next talk about issues that come with deep space travel. And then lastly, why do this at all? And we'll probably talk more about my reasons of wanting to go to Mars. So the history of Mars exploration. So it's really something that's from science fiction to reality. Many authors wrote about this like idea of like walking on another planet or going to that place you see up in the sky. But as time goes on, it's becoming something that we will most likely see in our lifetime, probably in the next couple of decades. We've sent, like I said before, we've sent probes, satellites, and rovers to the red planet. As you know, the UAE sent their probe, and Perseverance is about to launch soon. And so before like we send humans to Mars, we obviously have to learn more about the red planet, like kind of like what Rachel was talking about in her presentation, kind of why Mars is like it is today, and even though it was Earth-like before. So before we send humans, we have to learn more about what we're getting ourselves into. So in my opinion, I see Mars exploration as an international collaboration pursued by everyone around the world. It's not really just like, it's not only NASA going or only Canadian Space Agency going or ESA, JAXA, all the space agencies. It's going to be a collaboration between everyone if we really want to see the best results. And this also means with private companies too. It's not only going to be government agencies accomplishing this. And so the main goals for going to Mars is to learn more about the history of the planet. Why why it's like how it is today. And then also for some people, learning how to live on the planet, possibly colonizing in the future. Something that we also could see easily in the 21st century. So step one, preparation. How does this happen? How do we get there? So before we even can talk about going to Mars, we have to obviously talk about how exactly are we getting to Mars. So there's two systems, the two bigger systems that are being developed right now that are specifically made to get to Mars. And that's the SpaceX Starship by private company SpaceX, and then also NASA's Space Launch System, or SLS for short. And so some quick facts about each vehicle. So Starship is reusable, something that SpaceX has slowly perfected over the years. It can carry 100 metric tons. It stands over 120 meters high. And also they have this new engine technology that has never been used before, and also will utilize materials on Mars in order for it to work. And then some facts about NASA SLS. It's about 100 meters high, so slightly shorter than Starship. Its design is going to evolve over time. So once it's like completely evolved in its lifetime, it will be capable of sending 45 metric tons to space. And then its engines is the same engines that you saw on the space shuttle. So NASA really said refurbish. And then they will use the Orion spacecraft to carry astronauts and whatnot. So the first crew that will most likely be going to Mars is astronauts, probably not like a colony of people ready to move, packing their bags. And this could be like really any group. It could be a group of astronauts from agencies like NASA and CSA and whatnot, or it could be a group of private astronauts, people who may have signed up and did a lot of training. Who knows? But it's probably scientists and engineers before people leaving their belongings on Earth to go move. And so there's a lot of things that we obviously need to develop before going to Mars. But here are some of the things I wanted to highlight. So develop crew support. We're gonna obviously need to give enough supplies to a crew who's going on a super long mission, and provide, I'm going to talk about the habitat later, but provide habitat and just general support. Radiation protection, since we're not going to be in our nice Earth atmosphere that protects us from all the radiation in the outside universe. That's something that needs to be focused on. A habitat for away to Mars. If you're going to be on a mission with the same like 6 people for a very long time, you're going to need a place to live that will help acclimate yourself, let everybody on the crew with each other, and just be able to live peacefully for that 6 or 7 months. And then also something I want to highlight: mental health checks. You're gonna be alone if you're going on a mission to Mars, and that means alone for a super long time. You won't see your friends and family, whatnot. So it's super important to make sure that the mental health of the crew is at its highest, because you don't want anything terrible happening on a mission. So step 2, journey to Mars. So this is me talking about the trip from Earth to Mars. So like we've mentioned many times before, a mission will currently take around 6 to 8 months. And like Rachel mentioned, this is because of the alignment of the planets. And so the effects of microgravity for such a long time can affect the human body. So kind of like we were talking about before, like being on Mars can make you taller and whatnot, but also being in microgravity can affect how your body functions. And so being on a spaceship for 6 months and then landing on a planet and trying to learn how to walk, astronauts currently on the ISS already have like trouble like acclimating to Earth's gravity after a long mission. So this will be something to focus on. A crew of astronauts will have to deal with a lot of isolation, kind of like what I previously mentioned, being away from home and from any civilization like, I think Mars is around 200 million kilometers away from Earth on average, so you're pretty far. Something I wanted to mention is cryosleep, which is something I always find interesting, which is freezing your body so like you don't have to be awake for that 7 months that you might be on the mission for. So, something that's not been developed yet, but it's a possibility with all new technology developing in the future. And then entering the Martian atmosphere takes a lot more work than expected. So Earth's atmosphere, nice, pretty thick, keeps us safe. Martian atmosphere, not so great. It's pretty thin, and so usually when astronauts return from the International Space Station, they're on this crew module sort of thing that heats up in the atmosphere, and the atmosphere slows them down a bit. But with the Martians, with Mars's thin atmosphere, it's not going to work like that. So having the ability to slow yourself down is going to take a lot more work. So step 3, actually living on Mars, probably the most important part. So mission periods could be as short as a month or as long as a year, and this really just again depends on how like the planets are aligned, and it's most likely going to be on the longer side, so like a year to a year and a half. So you're away from any sort of civilization with the same 6 people for probably like 2 years. The Martian surface is not suitable for humans to live on. Like the air is toxic. It's mainly composed of carbon dioxide. So like we can't breathe it in. There's dust storms, there's dust everywhere. Like we mentioned before, the gravity is much lower. So you have to get used to basically hopping around, kind of like you saw the astronauts on the moon do. And so, yeah, habitat design is crucial. So kind of like what I said before for the journey to Mars, habitat design on Mars is also going to be important if you're going to be there for a year. And this leads me to talking about analog astronauts and what that is. So in December last year, I did this analog astronaut mission, which is basically when a group of people, it could be me, you, anyone who's like interested can participate. You go into like an isolated confined environment for a few days, or it could be weeks, and then you basically live like you're living on Mars. So I did this back in December with some company in California, and like NASA does these all the time. They have a center in Hawaii and whatnot. And so yeah, you do EVAs, you live in this like super like small environment with the same people, and it's a really good study to learning how to best design a habitat that's suitable for a cruise on Mars, and also like studying like the psychology of a crew, like how they interact with each other, like when do people reach their breaking point. So like if you ever get the chance to like do something like this and you're like interested in going to Mars, I definitely recommend doing this, because like you really see how you yourself perform in like a completely different environment. And then like if any of you guys are interested, like feel free to reach out. So yeah, that's on habitat design. And also that there's a whole field under bioastronautics that's dedicated to habitat design. So like if this sounds like something that's super interesting, you could literally go into this as a career. Next, you need enough supplies to survive without the help of Earth. So like I mentioned before, if I'm walking on Mars, I'm an astronaut, I like break my leg, I can't just go to the nearest Martian hospital and everything will be fine. So you're pretty far from Earth, and Earth can't like do anything to help you if like there's an emergency. You really have to survive yourself. And so supplies like 3D printers that can print tools and food and whatnot, and like also like vegetation, like you've seen in the movie The Martian, like Mark Watney growing potatoes on Mars, which is completely possible. That's something that can be real. It's things that are crucial in order to survive on the planet. And so, like I said before, the first people to go to Mars are probably going to be like scientists and engineers. So there's multiple things that they can study. So like water on Mars, that's a thing. And also the continuous search for life. Are we alone in this universe? And so there's always that saying that where there's water, there's life and whatnot. So that's something that astronauts will be able to study. The geology of Mars, the Martian atmosphere, and also volcanology, since Mars has one of the biggest volcanoes in the solar system. And so as more missions happen, there's going to be more and more colonies that will start to form. And like I said before, this is probably something that will happen before the year 2100, like something that like many of us can see in our lifetimes. And so yeah, people will start to live on Mars, work there, and we'll have a human colony on Mars. So now I talk about the return home. So like getting from Mars back to Earth, because the trip will not be one way for most people. So getting off the Martian surface is like a huge issue and probably one of the biggest issues. So like on Earth, like when there's a rocket launch, you have like mission support in like Houston, Texas, and you have like these crews that help you put it on your spacesuit. You like usually see all those people when you watch a crewed rocket launch to anywhere. On Mars, that's not going to happen, obviously. It's only you and your crew that has to do everything. So that's part of the main issue. And also, physically getting off with a rocket is going to be hard because you have to basically have a rocket there already in order to get off the surface. Something I mentioned before is that SpaceX's Starship is going to utilize methane in Martian rocks in order to use that as fuel and supply their vehicle to get off. So that's a solution to that. And then once again, I always talk about supplies. You need a lot of supplies, but especially when you're returning from Mars, if you want to bring back a lot of samples for all the scientists to study back on Earth, you're going to need like to be able to have a good ratio of supplies that can last a crew and also enough space to carry all the amazing science you're bringing back with you. And so once the crew gets back to Earth, things are pretty much smooth sailing. Obviously, I think anything can go wrong, but you're near Earth, communication isn't delayed by like 20 minutes. And so, yeah, and kind of what we've been talking about before, when a crew arrives, it's going to take a long time to get readjusted. So think about it like this. You're on Earth, you're used to regular gravity. You're an astronaut going to Mars. Then you're in space for like 7 months. So you're in microgravity. Then you're on Mars for like possibly a year and a half. That's 1/3 the gravity of Earth. Then you're back in space again for like 7 months, and then you're back to Earth. So imagine like not experienced Earth's gravity for like 2.5 years, and then you suddenly come back. Like I said before, astronauts already like have trouble like acclimating back to Earth's gravity. So like you can imagine what a Martian crew will feel. So yeah. So now I'm gonna talk about the issues with Martian mission. So I have the Mars, the God of War, what the planet is named after, because it kind of represents like Mars is not a welcoming place right now. It's not like come to my planet with open arms. It's gonna do anything in its possibility to make a mission to Mars super difficult. And so that includes like, I'm gonna be blunt here, that includes like possibly dying at any point in the mission. That's whether that's going up, going to Mars, landing, going back, whatever. Like at any point, something can go wrong. And that's one of the biggest issues of a Mars mission, because like I said before, if you're far away and something goes wrong, like you're on your own. And if you don't have the necessary supplies or the necessary like protocol to deal with things, like it's gonna be really bad. Like I said, isolation could like do terrible things to the human body and the human brain. So it's important to have a crew that knows how to work together, and also having those regular mental health checks so no one like ends up killing each other. And also things like radiation poisoning. Being exposed to that much radiation for so long, it's not good for your body, obviously, and it can up the chances of many diseases. So like that's just a few of the reasons that like a Mars missions have issues. And there's like tons of reasons I can go on forever. But that kind of leads me to, why would anyone willingly do this mission? Like what's the deal? So kind of like I said before, and like what many of you guys said, like I would go on a Mars mission, and yeah, it's pretty daunting. Anytime like I read up on this, I'm like, wow, that does sound bad, but I could probably die at any moment. But the way I see it is that once humans walk on Mars, that's gonna be the biggest thing humanity does in like this century, like over a moon missions, over anything. And so being able to be a part of something that's so much bigger than yourself is something that's super inspiring to me, and why I like want to dedicate my life to like doing science and everything, because like you're a part of something that you're than yourself, and you're doing work in science that will most likely benefit so many people to come like years from now. So that's like one of my bigger reasons. And then like of course Mars is pretty cool. So well, of course I would go to Mars. And then yeah, that's my presentation. So I have a question slide.
Awesome. You can stop sharing your screen there, Joalda. We
Oh,
can
yeah.
come back. And yeah, everyone get into the Q&A now. It's going to start filling up. And Rachel, you might as well come in here as well. We'll just have a good roundtable chat for the next 15 minutes or so as we get into Mars. And I've got a couple questions from that presentation for you, Joalda, because I want to get into this analog Mars mission because it sounds, well, first you said it's open to anyone. Like, what do you mean? Like, could I just like sign up and go to an analog Mars mission? Like, or do you have to, do you have to have some sort of credentials to get in?
So it's of course I guess like I guess I should have said everyone because of course you need like to apply, but like when I say anyone, like you don't need like there's no like height requirement or like any like requirements that you would need to like be an astronaut or anything. Like if you like want to get involved with an analog mission, you like usually like NASA has missions. I went through like this company called Mars Academy that has missions in California, and they're also doing like a lot of international stuff. So, and there's like tons of projects across the world. So like it's also kind of pricey. I should probably say that, but I got like a scholarship and whatnot. So, but yeah, it's something that's super cool. You kind of like really learn more about yourself as time goes on because like you're in this tiny cramped space, and I'm like, oh my gosh, why did I do this? But like, it's a really rewarding experience at the end, definitely.
Interesting. So how long were you there for?
So I was in my mission for like I think 4 days, but the NASA Center in Hawaii, I think their missions are usually 2 weeks or whatnot, or maybe a month. And then there's also the Mars Society that has analog missions, I think like maybe are a month long. So yeah, they could be like super long.
Was there any like I'm super like getting all like therapeutic here. Like was there any times when you felt like, oh, this is like I'm not sure, like when you, because you did talk about mental health, and I think that's a big part of the human journey to Mars. Like was there at any point that you felt sort of like if I had to like stay inside here with these people for like multiple months, that may be starting to strain on you? Did you ever have any of those feelings?
It wasn't more of like I hate like my crewmates and whatnot. It was more of like realizing communication is key because like everybody's usually on edge like by like the second or third day because you're like, oh my gosh, what am I doing? But like if you like don't communicate well with your crewmates, like it could easily lead to arguments, and that kind of happened during one day of our mission because like it was over like something super super dumb. But like yeah, I realized like I think if you know how to communicate with your crew, things should be fine. So yeah.
Rachel, would you go to an analog Mars camp?
For sure, but a little bit like you, I am also claustrophobic. So when you brought that up, I was like, ooh, spending many months in a small area does not sound like it'd be fun.
Yeah. Cool. There's a scene in Space Force. I don't know if anyone out there has seen Space Force. It's a silly show, but it's got some few moments. But there is a scene where the Steve Carell character does go to an analog base, and hijinks ensue. We're gonna get to some Q&A, but I did actually do a quick Google search. So anyone afterwards, I found that Wanderers short film that Joalda referenced off the top. Really cool, really short. I remember watching it a few years ago. People should check that out. So let's get to our Q&A, and our top question comes from Lauren. If there happens to be life, even if it's just bacteria, what steps are countries taking to not contaminate Mars? Joalda, go for it.
So I think I guess I should start off by saying I don't know what steps. Well, I kind of know. So like you guys may have heard like maybe like this happened like a year ago or so that like a bunch of like tardigrades were like released on the moon and whatnot. And so like contamination is like a huge deal. And I feel like many countries aren't taking the best route to it because like I think it kind of starts with like first like working together on like a mission like this because like if somebody's like not complying and then they just go like they find life and then they just like I don't know do whatever and like it could destroy many things. So I feel like I don't know if like if there's like really right now any steps being taken, but like I think the steps that need to be taken are first working together
Yeah.
at like the international level.
Yeah. I know it's very interesting because even right now, you know, in this pandemic, sorry to bring it back to the real world for a second, but, you know, we want people to cooperate. And that's kind of, you know, and then we could, you know, have some regulations, but sometimes they're hard to enforce, you know, but really when we're thinking about Mars exploration and probably why it's in this place where like the people have been talking about it, but they're kind of hesitant to like write some things into laws because once you start writing laws, things get complicated. And so what you're saying, Joalda, is that, you know, they're just taking the steps to have relationships with either the private companies or the countries that decide to go to Mars, right?
Yeah, definitely. Like it's complicated now because like I remember like I was just like reading a couple days ago about like the United States like trying to claim like space basically. So like I already like see it as a problem and like the working together, and I can already see like a problem with contamination issues and like not like respecting Martian life. But yeah, it definitely starts with like listening to each other and communicating.
Yeah, no, I did hear. I think it was it the Israeli probe that had the tardigrades on it when it
I
crashed.
think so.
Is that going to cause problems for future moon missions, Rachel? Those tardigrades?
I hope not. The water bears.
Maybe they'll have they will already set up their own little base before we get back to it. So, Joalda, you did talk about, you know, going to Mars. Even using these words, colonization is can be troublesome. You know, we have to be careful with our words. You know, going there, living there, as opposed to perhaps going as scientists and then coming back. But if we just focus on the living there aspect of it, do you think that'll be a private endeavor, or will that be something that actual countries may start to think about doing?
I honestly believe that it will be a private endeavor. Like, I just want to say, like, I completely disagree with like the term colonizing Mars, and it's just something I use since like people recognize it over like living on Mars. But I definitely think it'll like be a private endeavor at first because countries will have to like dedicate lots of their money to going to another planet and like claiming space and people already think there's too many problems here on Earth to like be like as a country saying like, hey, I am taking over this land.
Yeah. You know, there's a really interesting scene. I was just rereading one of my favorite books about Mars. I read Mars, just got right back there, Kim Stanley Robinson. And it has goes into all of the politics. And there's this one passage that talk about there are these Arabic people. They were called Bedouins, and they didn't really have any attachment to a specific land, and that's why they're called Bedouins. They were kind of like traveling around, and then when it came to all of the people going to Mars, they were the first ones to kind of go because they never had any land to sort of claim to, and they were all excited, like, yeah, let's go to Mars. Let's set up there. And so there might be some interesting political things that kind of come up once people start to go to Mars, and if land here on this planet starts to become an issue. You know, there was one thing. I'm going to throw up a quick little poll here, Joalda, which I stole from your Twitter, which is amazing, by the way. We'll throw up your Twitter a little bit afterwards. You've been doing some really cool stuff. But one question that you had posed, which I thought was a really good one for people to kind of think about, was when do people think we're going to get to Mars? Is it going to be this decade, the 2020s, the 2030s, the 2040s, 2050s, later than that, never? You know, Joalda, where do you weigh on this?
So I feel like with like how things are moving right now, I'm expecting like either like mid to late 2030s. Like when I saw like the poll results on my Twitter, like it was like exactly how I expected it to be. Like most people like are like hopeful for the 2030s. There's maybe people who are too optimistic about the 2020s,
Yeah.
and like obviously people who are like more conservative and think we'll like do it later. And so I definitely think like mid to late 2030s, but like things can change obviously. Like who knows?
Yeah. Rachel, where do you weigh on this question?
I think it's almost similar to JWST in that it will keep being delayed and delayed until we finally get it right, finally get 100% the A-OK, and then we'll get there.
Category.
Yeah.
You know, I voted on your Twitter, Joalda, and I said the 2040s, and that was like, because I think, you know, the classic knowledge is 2030s, but yeah, I just sort of think that there's going to be delays, but you never know. There could be some maverick cowboy that gets out there before it just wants to be like the first person. So if we say, when will humans set foot on Mars, with a coordinated effort, maybe a long time, but I sort of feel that maybe there might be some rich person, maybe Elon Musk or maybe Jeff Bezos, that's able to be like, yeah, we're going to get some cowboy to get out there. I say cowboy in like that way of just like, yeah, I'm just doing it, not really like thinking things through. But here's the results of our poll, sort of similar to yours, Joalda. 31% 2030s and 2040s, and then sort of on the outskirts there. So interesting, sort of like, you know, perception, you know, like we're close.
Yeah.
And that's really exciting too. Like and for you, like you're at the start of your career, and you know, and thinking about what are you going to be doing, you know, in the 2030s, 2040s, and how maybe you'll be going to Mars. Maybe Rachel, you'll be going too. You know, and maybe it'll be totally different. Maybe we'll have figured out that maybe that's not the right thing, and we're just sending robot analogs. Who knows? Let's get to some questions, because we've been bantering a lot. We've only got a few more questions. Serenia wants to ask, what is the primary objective of NASA with humans landing on Mars? So what is NASA trying to do when they get to Mars?
So from what I understand, NASA's mainly just trying to do like a mission to Mars, land there, do science, come back, and that's like really the basics of it. Nothing more or nothing less right now.
Yeah. So perseverance, insight, curiosity, they're all there to do science. And really ultimately, like, what are they trying to figure out? Like, why are we, I guess like the big question is like, so if we're not sending humans, what do we need to find out about Mars just by sending robots there?
So, I mean, with robots, like, they tell, like, since, like, we're not, like, there and we can't, like, be in the field and, like, picking up rocks and everything, they're, like, I guess, like, I would say, like, there are placeholders for, like, learning more about, like, the geology and the history, because, like, scientists like know basically the basic history of like what happened to Mars and like its atmosphere and why it's like dead, but like we don't know like the specifics, and that's what a rover does. But once a human gets there, I think I saw a statistic that what a rover can do in a few weeks, a human can do like in a few hours. So yeah.
So efficiency is what you're saying.
Yeah.
Let's get to TS Nitchuk, maybe. If the average surface temperature on Mars is minus 63 degrees Celsius, sorry, Joel, that we're using Celsius up here in Canada. Don't know what that would be in Fahrenheit, but pretty cold. How would a human adjust to such a drastic change?
So for I guess like a science mission, that's where spacesuits into play, with like systems that like can keep the astronauts warm. But I guess for long term, like at the beginning, I assumed that like humans would be like living in domes and whatnot, so that wouldn't be much of a problem again. But like of course people like are thinking of like terraforming the planet and whatnot, and then that would like make things a lot hotter and I guess up to human temperature, whatever that is.
Right. So we need to get some good spacesuits, and of course, you know, find a way to get some space heaters into those. I just make a pun. Oh, I'm sorry. Very quick, maybe Rachel or Joalda, is there a place that we can send people if they want to be an analog astronaut? Like, is there a Canadian equivalent, Rachel, that you know about? Or Joalda, is there a quick Google search people could do to look to be analog astronaut?
Yeah, if you quickly search for sorry if I like cut you off, Rachel, but
I don't know.
if you quickly search Mars Desert Research Center, not Siri, Mars Desert Research Station, I think that's the name. That's the one that the Mars Society has, and that's like one of the most like I guess famous analog astronaut missions.
Okay.
And then like from there you could probably find more. So that's by Mars Society.
Okay, Rachel, do you know of any?
I know that there's something called LEAD, which is the Lunar Exploration Analog Development for the CSA, but that's for missions to the moon instead. Yeah, which is a little bit sooner than going to Mars.
All right. Let's see how many we can get through in these next few minutes here. Sean Cullen asks, when does SpaceX and NASA plan on launching their manned missions to Mars? Like, so do we know any timetables for SpaceX and NASA on the, like, when does, like, I guess, well, like, when do they hope?
So I know for NASA, they hope for like early 2030s or mid 2030s.
Yeah.
SpaceX is more optimistic, and they're thinking late 2020s, but that's probably going to be pushed back to the 2030s.
Yeah, it certainly seems wild. Back to Srenya, how do we make a decision that now is the time for us to travel to Mars? Is it based on the results of the robotic expeditions that we don't have enough information for us to handle? So, like you're saying, Joalda, like we need to get to that next level quicker. Is that sort of weigh in to this decision on sending humans?
That's a pretty good question. I don't know what's like the driving factor of like now being the time, but I think it's just always been like the next step. Like we walked on the moon and like, all right, now we have to go bigger, go to Mars and like see what we can do. So that's the way I see it. It's just like, well, you gotta like I guess go big or go home if you want to say it like that. But
Yeah. And I guess our final question, maybe Rachel will be able to so stick around and answer some of the last ones. So on the Mars 2020 rover, you were able to send in your names. Joelda or Rachel, did either of you send in your names on the Mars 2020 rover? Yeah. Of course. I mean, if we can't get there in person, at least our names and spirits are going to be there on the Mars 2020. Awesome. Well, Joelda, Rachel, thank you both so much for your time. Joelda, thank you for staying up out there in Chicago. Where can people find out more about the work that you do? And certainly on Twitter, you've been doing some really cool stuff. What's your Twitter handle?
yeah, so my Twitter handle is Solar System, but with two R's. I couldn't get the original handle. And so yeah, that's where I do a lot of science communication on my Twitter account. So I do a lot of threads. That's like my thing. So if you want to check this out.
Cool.
And then I have a website, I guess. I could drop that in the chat.
Yeah, just throw it into the chat there. And you're working at JPL. We didn't actually get into that. Like, what are you actually doing for JPL right now?
Yeah, so I'm actually doing more Earth science, ironically, at JPL, so like nothing regarding Mars. And so I'm working on this mission called EcoStress, which is on the International Space Station right now. And it basically looks at evapotranspiration, which is just evaporation and transpiration from plants in the soil and whatnot, and just looking at that data.
Awesome. Well, Joelda, again, thank you so much. Everyone out there in Zoom, thank you so much. We're going to post into the chat here, but also going to be posting elsewhere as well that, well, not to the public, you get this special exclusive to my interview with Dr. Anna Mittelholz, so you can learn about the latest on Mars Insight. And of course, if you are able to donate anything, if you've enjoyed any of these programs, of course, Rachel and I are still working from home. We haven't opened up the Space Center quite yet, but hopefully soon. You can donate to us. You can go onto our website, spacecenter.ca, and find the donate now. Really appreciate, hope to see you all in person soon. And of course, these online events, we're going to keep on doing them. In fact, tomorrow, Rachel and I are going to be back here on YouTube. You can go straight to the YouTube. You don't have to come into the Zoom. We are going to be chatting with Canadian astronaut Joshua Kutrick. So you definitely want to get in there. That was a popular one last time we talked with Jeremy Hansen, the other Canadian astronaut. So 2 o'clock on YouTube. Come with your questions. It's going to be a fun one. And then, of course, every Thursday at 2 p.m. All right. From me, Michael from the Space Center, Rachel, Joalda, thank you all so much. See you next time.